What's up guys? Today we are going to learn about oxidization, oxidizing agent or reducing agent depending on different concept, and also we'll learn how to remember the oxidation reaction or reaction or redox reaction. However, let's get started. Well, oxidizing agent according to classical concept. Oxidizing agent can provide oxygen to another substance, or oxidizing agent can remove hydrogen from another substance. These are the example of oxidizing agent like hydrogen peroxide, potassium dichromate, right? So oxidizing agent will provide oxygen or remove hydrogen. On the other hand, reducing agent can provide hydrogen and remove oxygen from uh, other compound like hydrogen, ferrous sulfate, tannous chloride, sulfur dioxide, or hydrogen sulfide. Compare here, uh, oxidizing agent provide oxygen and reducing agent provide hydrogen. Oxidizing agent remove hydrogen and reducing agent provide hydrogen. That is, provide oxygen, provide hydrogen, remove hydrogen, remove oxygen. So these are the comparison between reducing agent and oxidizing agent, right? Keep patience, you will learn better. Well, according to classical concept, oxidation reaction or oxidation is gain of oxygen. On the other hand, reduction is loss of oxygen, right? Well, here you see ferrous oxide, right? From ferrous oxide we are getting iron only. So here, uh, loss of oxygen. Well, here is oxygen, but here that is no oxygen. That is, this is reduction reaction, right? On the other hand, this is carbon monoxide, and here carbon dioxide. Gain of oxygen. So this is oxidation reaction. Oxidation or reduction reaction are complementary and simultaneous, so they will occur together, and these two reactions are called redox reaction, right? Well, oxidizing agent give oxygen to another substance, right? Here you see this is ferric oxide is oxidizing agent because it is giving oxygen to carbon monoxide. Well, right. On the other hand, reducing agent remove oxygen from another substance. Well, here carbon monoxide is a reducing agent because it is removing oxygen from ferric oxide, right? So that is reducing agent will take oxygen from oxidizing agent, right? Oxidizing agent is reduced, and reducing agent is oxidized, right? Please remember it. Well, here is a example. Well, this is methanol and this is ethanol. So uh, if you observe here, then you can see, uh, we see that here is the loss of hydrogen, right? There is more hydrogen here, but there is lower hydrogen here. So loss of hydrogen means oxidation, right? So according to classical concept, loss of hydrogen is called oxidation, right? Well, in this reaction, from ethanol to ethanol, where in this reaction the number of hydrogen is increasing. That is, reduction is the gain of hydrogen. So this is reduction reaction. Please remember, oxidation is loss of hydrogen and reduction is gain of hydrogen. This is the definition on depending on the classical concept, right? This is most important to you. Well, now would like to discuss the Valency concept of oxidizing agent and reducing agent. According to Valency concept, oxidizing agents are that kind of substances that achieve higher valency. Well, that is, the valency will increase. This is stannous chloride and this is chloride, but this is stannic chloride. So here the valency of Sn is 2, but here the valency of Sn is 4. That is, it is receiving or achieving higher valency. That is why this is oxidizing agent. Substances that achieve higher valency. So here the valency of Sn is 2, but here is 4. So it is gaining valency. So this is oxidizing agent, right? On the other hand, reducing agent achieve lower valency. That is, the valency will decrease. Here the valency of mercury is 2, and but here the valency of mercury is 1, right? So this compound is reducing agent. So this is the definition depending on the Valency concept, right? Well, now I would like to discuss the reducing agent and oxidizing agent depending on electronic concept. This is important, and in this present time we'll use this concept. So reducing agent, that is, reducing agent provide an electron or more electrons, right? For example, zinc releases 2 electron, right? So according to electronic concept, zinc here is a reducing agent, and here SN10 tennis ion, the oxidation state is 2 plus, but here the oxidation state of Sn is 4 plus. That is, Sn is releasing electron. Well, so here Sn is a reducing agent, right? On the other hand, oxidizing agent will accept an electron. Here we have to add an, accept an electron or more electrons, right? Chlorine plus electron, chloride, and ferric ion plus electron, uh, ferrous ion, right? So here this atom is accepting electron, so this is oxidizing agent, right? After receiving electron, it is reduced, right? Well, after giving electron, it is oxidized. Well, let me give you some formula that will help you to remember oxidation reaction and reduction reaction easily. Well, OIL. Well means oxidation is lost by electron. Well, oxidation is oxidation is loss of electron. Reduction is gain of electron. If you remember these two words, then the probability to remember oxidation and reduction reaction is higher. Well, now let me say you something. here A is releasing electron, right? Compound A is losing electron and we are getting this, right? So loss of electron means oxidation, right? And this A is oxidized by releasing electron, right? On the other hand, B is gaining electron. Well, so gains of electron is called reduction, right? And this is oxidizing agent after taking electron will be reduced. Many students may confused about this situation, but this structure may be helpful for them to understand this reaction easily. I hope you have understand what I want to mean to you. Let me know what I can uh, let me know how I can help you about these two reactions. Thank you for viewing this video. Be well.